Hi, my name is Fazil. I'm from Mathematic. In this video, we are going to discuss a problem involving mathematical induction. I'll give you a statement which is a ridiculous statement, and I will prove that statement using the principles of mathematical induction, which obviously means that the proof is going to be wrong because we cannot mathematically prove wrong things. But it is quite an interesting task to identify what is wrong in the following proof. So here we go. All horses have same color. So this is the statement I was talking about, and this statement is quite obviously false, but still I'm going to prove the statement using the principles of mathematical induction. But wait, this statement, first of all, it does not even look like a mathematical statement. So our first task is to rephrase this statement into a proper mathematical statement. Only then we can use mathematical techniques to prove it. So let me rephrase it. Any set containing n number of horses will have horses of same color. So this second statement is the mathematical equivalent of the given statement. Let me denote the statement P of n as we always do in mathematical induction. So P of n represents the statement any set containing n number of horses will have horses of same color. First, let us check if the statement is true for P of 1. So consider P of 1. So what is P of 1? Any set of just one horse will have horses of same color. So this statement is quite obviously true, because in that set we just have one horse. We don't even have any second horse to compare the color of first horse with. Therefore this is automatically true. So P of 1 is true. Now let us assume the same statement to be true for some natural number k. Let us assume that P of k is true for some k belonging to set of all natural numbers. So what did we basically assume? We assume that any set, literally any set of k horses will have horses of same color. So we assume P of k to be true. Now based on this assumption alone, we are now going to prove that P of k plus 1 is true. So consider P of k plus 1. Consider P of k plus 1, and the statement is any set of k plus 1 number of horses will have horses of same color. Now we are not assuming anything about P of k plus 1. We are going to prove that it is correct. So let us just consider any random set of k plus 1 number of horses. I denote that set by capital H. Consider capital H, which is a set containing k plus 1 number of horses. It goes like this: h1, h2, h3, it goes on up to hk and hk plus 1. And of course h1, h2, h3, all these things, they denote horses. So this capital H is set of all k plus 1 number of horses. It's a set containing k plus 1 number of horses. Now if you know basics of set theory, we can clearly see that this set can be written like union of the following two sets, H1, H2, H3, so on up to Hk, union H2, H3, so on up to Hk plus 1. Remember, this is a set containing exactly k number of horses, because from the previous set I just removed one horse, which is k plus first horse, so what remains is k number of horses. Union, the second set, is obtained by removing H1 alone from the previous set, so there are remaining k number of horses. So this is a set containing k number of horses, and this is another set containing k number of horses. And sometime back we assumed that P of k is true, which means any set containing k number of horses will have horses of same color. So based on that, we can now conclude that this set has horses of same color. Even the other set obeys the same property. It has horses of same color. And do we have anything common between these two sets? Is there at least one horse that is common to both the sets? And the answer is yes. We have H2. And of course there may be something more than H2. For example, even H3 is common, but at least one is enough. So H2 is a common horse. Since this set has horses of same color, and even this set has horses of same color, and these two sets, they have one horse in common, we can now conclude that this entire set has horses of same color. So this implies H, which is the collection of H1, H2, H3, so on up to Hk and Hk plus 1, has horses of same color. So this implies that P of k plus 1 is true, because we just randomly took a set containing k plus 1 number of horses. We have written that set like union of two sets where both of them have exactly k number of horses. So therefore we can conclude that this will have all horses of same color, and this also has all horses of same color. So, and they also have something in common. Therefore this entire collection, which is same as the previous one, will have horses of same color. So we proved P of k plus 1 is true. Therefore, by the principles of mathematical induction, we have proved that P of n is true for all n belonging to set of all natural numbers. By the way, you remember what is P of n? It simply means any set containing n number of horses will have horses of same color, and this literally means any set. So you take a set of 10 horses, it will have all horses of same color. 1,000 horses or million horses, it will surely have horses of same color. So which is exactly like proving that all horses, literally all horses have same color. So now it is time to find out what is wrong in this proof. Surely there is something wrong somewhere in this proof, but we have to identify what is wrong in this proof. And thank you for watching our videos, and subscribe to our channel to watch more awesome videos.